Evening everyone. So this is question number 8.11 for the mechanical properties of the solid. So I will try to solve this NCERT questions. Before that we need to read the question. A 14.5 kg mass fastened to the end of the steel wire of an stretched length 1 meter and is railed in a vertical circle with an angular velocity 2 revolution per second at the bottom of the circle. The cross-sectional area of the wire is given like this: 0.065 centimeter square. Calculate the elongation of the wire when the mass is at the lowest point of its path. Let us try to figure out the situation what they are asking. Let us consider there is a string, and in a string there is a mass which is attached, and the mass is given as 14.5 kg. Okay, now this has been railed from this point. This has been railed in such a way that it will create a vertical circle, not a horizontal circle. If they will talk about the horizontal circle, so they will make a circle like this. This is the center, there will be a road, it will move in this direction. Okay, but here it is a different case in the vertical circle. So at the bottom they have a angular velocity as 2 revolution per second. So this is so the angular velocity is 2 revolution per second. Means what happen, in 1 second it will move 2 times, it will create a 2 revolution. It means that omega can be written as 2 into 2 pi, because if it will create a 1 revolution in 1 second, so we have to take 2 pi. If it is creating a 2 revolution per second, so it is 4 pi radian per second. Okay, so we have got this omega. Now try to understand here, when we talk about the elongation, let us erase this. Yeah, when we talk about the elongation, when you will try to move or rail, so due to load, what will happen, there will be an elongation of the load. It may be delta x. So you know that how to find the elongation. So we have a basic formula: stress is equal to Young modulus of elasticity into strain. Now the stress is equal to y into change in length by original length. So change in length is our main focus. Change in length is equal to sigma into L by y. Sigma, that is equal to force. For here, force by area into y into L. Okay, so since the elongation, we have got the elongation formula, but we need to find force. Area is given, y Young modulus of elasticity we know, L is given. Okay, so we need to find force. Force means how much force is being acted here. So if we draw the free body diagram, then what will happen, let us consider this is the mass. So in string, tension is acting upward, okay, and the mg is acting downward. Okay, so acceleration, pseudo acceleration is there, so force will act pseudo force, that is m omega square act will act downward, and mg will act downward. So finally we have a tension T is equal to mg plus m omega square into r. So now tension will be the only acting force, so we have to apply that force. Okay, so if you find tension, that means we have got the tension. So tension finally is equal to mass is common, so take it g plus omega square into r. So m is how much, m is 14.5 5 kg, G is 9.8 plus omega square means 4 pi whole square into what is the radius? Reeled in a vertical with the velocity इतना cross sectional area इतना calculate the elongation. So length will be the radius only. So length is 1. So finally when we calculate this, so how much we are getting? We are getting 2437, right? So this amount of tension is we are getting. Okay, now let us consider delta x by L. Sorry, let us consider now tension is there. Now we need to find delta L. So here delta L, so put the values of delta L. Delta L is equal to force, that is tension, is equal to 2437 into length is your 1 divided by area they have given 0.065 centimeter square, so convert it into meter squared. So this is minus 4 into y, that is y. What is y? Y is the Young modulus of elasticity, so this is equal to 200 into 10 to the power 9. So when we calculate this, so we will get 1.87 into 10 to the power minus 3 meter, or if you round it off, so we will get 2 mm approximately. This amount of elongation will happen in this case. So I hope you have understood this. Now let us discuss question number 8.12. Compute the bulk modulus of water from flowing data. Initial volume is V initial is, they have given V initial, that is initial volume is 100 liter, and when pressure increases, so let us consider this is the initial volume. Now what happened when pressure increases, that is 100.0 atmospheric pressure, when pressure is extra pressure is added. So earlier a normal atmospheric pressure we have 100 liter. When we added 100 atmospheric pressure, so final volume will, I think, reduce. Why? Because when you compress, so when you increase the pressure, so it will reduce. So final volume, so V final will be not 100.5, so it will be 99.5 liter, right? 99.5 liter. Okay, now compare the bulk modulus of water with that of the air at a constant temperature. So first of all, we need to find the bulk modulus of the air. So we know that the bulk modulus of the water, so bulk modulus of water is equal to P excess or excess pressure divided by change in a volume divided by original volume, but it will be negative because it will decrease, so volume is decreasing, so that's why we have put this. So now bulk modulus, we are going to get it bulk modulus as excess pressure is 100 atmospheric pressure is the excess one whatever we are applying, but we need to convert it into Newton per meter square. So this is equal to 1.013 as per they have given also, 1.1013 into 10 to the power 5 Pascal or Newton per meter square, whatever you can assume. Now the volume, change in volume is how much? So change in volume is final minus initial, so this will be negative, so this will be 0 minus 0.5. So change in volume is minus 0.5, so minus 0.5 divided by volume, original volume was 100 liter. So when we do this calculation, so what we will get, we are going to get 2, so it will be 20,000 into 1.013 into 10 to the power 5 divided by, not divided by, just simply you have to multiply this. So finally we will get 2.026 into 10 to the power 9 Newton per meter square. Now we know that the so we have got bulk modulus of water. Bulk modulus of water. Okay, so whatever they are asking, so we have done this bulk modulus of water. Now you know that bulk modulus of air is what? If we talk about bulk modulus of air, so its value is approximately equal to 1 into 10 to the power 5 Newton per meter. So it is, as compared to this, which is very less, very less. Okay, now we know that the compressibility is inverse of bulk modulus. So if bulk modulus is high, compressibility is less. If bulk modulus is less, so compressibility will be high. Okay, so from here we conclude that water has higher bulk modulus bulk modulus as compared to air. Okay, so water has a higher bulk modulus as compared to air. Got it? So that's why water is less compressible. Water is less compressible. Okay, so I hope you have understood this question. Now let us do next question. Now let us do this question. This is 8.13. What is the density of the water at a depth where the pressure is 80 atmospheric pressure, given that its density at the surface is 1.03 into 10 to the power 3 kg per meter cube. So let us draw the scenario. The scenario is that this is the situation. Okay, this is the situation. Got it? Now in this situation, let us consider there is a 1 meter cube volume. So at this situation, the pressure is equal to, if I will consider this as a 1, if I will consider this area as a 2, so pressure at this is how much? 1 atmospheric pressure. And at this point, the pressure, that is if this is your P1 and if this is your P2, so P2 is your 80 atmospheric pressure. Okay, got it? We have got P1 as well as P2. Now let us consider, if I will consider V1 as volume as 1 meter cube, so V2 is the volume at this, we don't know. So volume will decrease for same mass. Volume will decrease. Why volume will decrease? Because if you apply a pressure, so if pressure will increase, so definitely there will be a volume decrement in the volume. Okay, now let us suppose we know that the bulk modulus of the water, bulk modulus is how much? Bulk modulus B is equal to P excess or excess pressure divided by change in a volume by original volume. Okay, now because we want to know that density at the second position, or row 2 we want to find. Row 1 is mass by V1, and row 2 we want to find. So how you will find? So let us assume that B is bulk modulus is equal to P excess by delta B. So now we have assumed that for case 1, V1 is equal to 1 meter cube. So from here we will get change in a volume is equal to P excess divided by bulk modulus of the water. So what is P excess? So P excess is equal to 79 into 1.01 into 10 to the power 5 divided by What is bulk modulus? So bulk modulus is equal to, modulus of a water is generally 2.2 into 10 to the power 9. Okay, now if we find change in a volume, so if we calculate, so change in a volume will be approximately is equal to 3.63 into 10 to the power minus 3 meter cube. So we have got change in a volume. Now we have got change in a volume. Now we need to find, actually we need to find a density at the position 2. Now we know that density rho 1 is given as 1.03 into 10 to the power 3 kg per meter cube. Okay, so this they have given. So we know that volume V1 is equal to mass by density, so mass m1 m by rho 1. So since for both the position the mass, we are taking the mass, same amount of mass will be there, but only volume will be decreased. Okay, so if we talk about the, density rho 2, so rho 2 will be equal to, rho 2 is equal to m by V2, or we can also write here V2 is equal to m by rho 2. Okay, now can we write here V1 minus V2 is the change in a volume. So this is equal to, the given change in a volume is how much? We have found change in a volume is equal to 3.63 into 10 to the power minus 3 meter cube. Okay, now change in a volume, so in a volume we have we can rewrite this equation, m by rho 1 minus m by rho 2 is equal to 3.63 into 10 to the power minus 3. Now if m is constant, so m is constant for this, so we can also rewrite this equation, 1 by rho 1 minus 1 by rho 2 is equal to 3.63 into 10 to the power minus 3. Okay, now here can we write here m into rho 2 minus rho 1 by rho 2 into rho 1 is equal to 3.63 into 10 to the power minus 3. Now m by rho 1 is equal to V1, and V1 into rho 2 minus rho 1 divided by rho 2 is equal to 3.63 into 10 to the power minus 3. So V1 we have already taken V1 as a 1 meter cube. So where we have final equation, rho 2 minus rho 1 is equal to rho 2 into 3.63 into 10 to the power minus 3. Now we have already values rho 1, so we have already a value of rho 1. Rho 1 is 1.03 into 10 to the power 3 cube. So if we do this calculation, so finally we will, what we will get, see here, rho 2 minus rho 1 is equal to, rho 2 minus rho 1 is equal to rho 2 into 3.63 into 10 to the power minus 3. Okay, so if you want to take a common rho 2, so this will be 1 minus 3.63 into 10 to the power minus 3. This is equal to rho 1. Okay, now we have a values, rho 2 is equal to rho 1. We have rho 1 is equal to 1.03 into 10 to the power 3. Rho 1 is equal to 1.03 into 10 to the power 3 divided by 1 minus 3.63 into 10 to the power minus 3. So if you will calculate this, so you will get rho 2 is equal to 1.034 into 10 to the power 3 kg per meter cube. So when you will see this thing, so you will see that the result, by using result, by seeing the result rho 2 is only a slight change in a density, changes in density, and this only happened because its compressibility is very less. Okay, so I hope you have understood this question. Now see here 8.14. In question they are asking, compute the fractional change in a volume of a glass slab when subjected to a hydraulic pressure of 10 atmospheric pressure. So they have given excess pressure P excess is equal to 10 atmospheric pressure, that is equal to 10 into 1.01 into 10 power 5. Okay, they are asking me that what is the volumetric change, or what is the fractional change, that is del V by V is how much. We know that del V by V, or we know that bulk modulus is equal to P excess by del V by V. Okay, now we need to put the value so that we will get del V by V. So it is in negative, so let us consider del V by V is equal to P excess divided by bulk modulus of the glass. Because we are talking about glass, so we have to put the bulk modulus of the glass only. Now P axis is 10 into 1.01 into 10 to the power 5 at Newton per meter square, and bulk modulus of the glass is 37 into 10 to the power 9. When we see in the data book, so you will get this, or in exam they will provide you this data. So bulk modulus B for the glass is 37 into 10 power 9. So when we calculate it, so we are getting the result 2.73 into 10 to the power minus 3. So this is a change in a volume by original volume. Okay, so this is what about what they are talking about, the fractional change in a volume. Fractional change in volume. So I hope you have understood this. So this is the final answer. So this is minus 3. Now let us do next question. Determine the volume contraction of the solid copper cube 10 centimeter of an edge. So there is a solid copper cube, it has a 10 centimeter edge when subjected to a hydraulic pressure of 7 into 10 to the power 6 Pascal. Okay, so here we know that the bulk modulus is equal to excess pressure divided by change in volume by original volume. I am taking here all the things as a positive only. So change in a volume by original volume is equal to P excess divided by bulk modulus. So bulk modulus of the copper cube. So we have already P excess is equal to 7 into 10 power 6 Pascal, 7.0 into 10 power 6 Pascal. And what is the value of the bulk modulus? So bulk modulus value of the copper. So for B, copper is equal to 140 into 10 power 9 Newton per meter square. So here we can find put here 140 into 10 to the power 9. Okay, now we have got change in volume by original volume, but they are asking you to determine the volume contraction. Volume contraction means what? They are asking about change in volume only. So change in volume is equal to V into when we calculate this, so how much we are getting when we calculate this? So 7 V into 7 2 it will be 20 into 10 power cube. So the what is the volume? So volume, we need to put here volume. Volume, if we put the volume, then we will get the answer. Okay, so volume of the solid copper cube. So original volume of the solid copper cube, so it is your 10 cube into 10 to the power minus 6. So this will be 10 to the power minus 3. So finally it will be 10 to the power minus 3 meter cube by 20 into 10 to the power 3. So we will get 10 to the power minus 6 divided by 20. Okay, so this will be 5 into 10 to the power minus 8 meter cube. So this is the change in a volume. If you want it in centimeter, so you can also get the volume change in a volume in a centimeter, that is equal to 0.05 centimeter cube. So our answer or our solution will be 0.05 centimeter cube. I hope you have understood this. Thank you for joining my class, and hope for next class you may get the next question. Thank you.